Hello, good afternoon. Welcome to, I guess, what is the last session of Google I/O. I'm here to talk to you about a topic that's near and dear to my heart, which is JavaScript programming in the large with Clojure tools. My name is Michael Bolin. As you can see, I have my speaker meter URL up there if you want to give me feedback. I do talk about Clojure a bit, so feedback would be great. But let's get started. So first of all, something I would actually like to clarify is that kind of who am I and why did they let me up here? Because actually, I don't work at Google. I used to work at Google, and while I was there, I worked on Google Calendar. I did a lot of the front-end development for that, and then also majority of the front-end development on Google Tasks. And then post-Google, I wrote a book called Clojure, the Definitive Guide. Maybe some of you have it. And basically, around the time when, about a year and a half ago, when Google open sourced Clojure, I just felt very strongly that this is a really important toolkit in terms of moving the web forward, in terms of enabling people to make really fast web applications. And that's what makes the web better for everyone, when people can build higher quality applications. So I've done a bit of work in the realm of doing some large JavaScript development, and that's what we're going to talk about today. So first, I should clarify, or at least give some sort of definition for what I mean by programming in the large. Just to throw out, I'm just going to make up some numbers, but more properties. Let's say 30,000 lines of code. Let's say that's kind of in the programming in the large. Another aspect is having a large team. Once you have more people, because you need more people to build a bigger application, now you also have this communication overhead that you have to think about. I think that this is really important in terms of JavaScript, because a lot of people are used to just copying and pasting some code they find on the web to decorate some page that they have, and that's kind of what their impression of JavaScript programming is, and that they don't really have an idea of how to get to the 10 lines of code that they copied to the 30,000 line JavaScript application. And another aspect of this is a longer development cycle. This is significant in terms of, if you work at a larger company, people may roll on and off your team. They're going to have to be able to pick up and dive into a large code base that they're not familiar with. Also, over a 6-month period, you yourself may not even remember what the code that you did 6 months ago. So it needs to be organized. You need to have some way of laying it out such that you can come back to it, anyone else can come into it, because this is what's going to enable you to build more complex and interesting applications. Not that everything needs to be complex, absolutely not, but there's a certain class of applications that are really interesting that we want to see brought to the web, and for that, it just takes a different you need to take a different tack in terms of how you organize your team and organize your code and make sure that you can make interesting progress. So this is the area that I'm calling JavaScript programming in the large, and that's where I think Clojure really fits in and speaks to that. So today, if you wanted to build a rich internet application, or an RIA, a lot of these are thought of as single-page applications, such as Gmail and Calendar, where you go, you log in, you actually don't really reload the page or change URLs, and maybe the fragment changes and it keeps track of your state, but you load a large bundle of JavaScript at the beginning. Perhaps you navigate through the app, exercise certain features, more JavaScript gets loaded, but basically you're using this one thing where everything is in memory on that single page. So if you wanted to create this rich experience, something that's more akin to a desktop app, obviously we're doing a lot of stuff with HTML5 right now, but let's think about what some of your options would be. So the first one is to use a plugin, such as Java or Flash. Some people maybe remember Java applets, which were going to be the greatest thing, and they were going to save the web, and we were going to be able to write all our things in Swing, and they're all going to be purple and gray, and it was going to be great. But the problem was it took like half an hour or something for that Flash plugin, or the Java plugin to load, and you were looking at that coffee cup, assuming you could even figure out how to download it. And then Flash. Flash is obviously a lot snappier than Java, still, and is very popular today. Obviously, when YouTube first came out, I don't know if there would have been a YouTube if there weren't a Flash plugin. But certainly, Apple has thrown down the gauntlet. On iOS, Flash is a non-starter. So if you want to have a code base that you can use across different devices, and supporting iOS is important to you, then Flash is not really a reasonable option. So another option which is good for building an RIA is Gwt. So I'm sure there's a lot of people here who use Gwt. Certainly a lot of people at this conference have been talking a lot about GWT. And so if you're familiar with it, the idea is that basically you write your application in a language that's more familiar to you. In the case of GWT, it's Java. And then the tool takes care of translating your Java code into JavaScript. And certainly a lot of people have written a lot of interesting things with GWT. Even this morning, I believe the Angry Birds folks said that their stuff was written in GWT. So clearly you can get a lot done using it. But at the same time, there's actually a lot of really great things that JavaScript has that Java does not have, such as first-order functions is a really big one, and a really natural use of closures. Passing a function around as a parameter in Java is actually incredibly awkward, yet it's also very straightforward when you do it in JavaScript. Similarly, there's APIs of the browser with HTML5. New things are coming out all the time. If JavaScript, you can use these things very directly. In GWT, you need to wrap them in JSNI, or someone else has to do that work for you. So if you really care about getting close to the metal of the browser, so to speak, GWT has ways to get to it, but it's not as natural as if you were using the language that the browser speaks, which is JavaScript. So the way that I propose and have built rich internet applications is writing lots of JavaScript, because it is awesome. And when I say lots, I do mean lots. The last project I worked on, we wrote 70,000 lines of JavaScript as our application. And we did it using Clojure. It has, as I mentioned, JavaScript has first-order functions. It also has regular expression literals, similar to Perl. It has a prototype-based inheritance mechanism that Java doesn't have and other languages don't have. It actually was inspired by this other language called Self. So there's a lot of neat things that you get when you write in JavaScript, in addition to being close to the browser. But also as a language, it is a very good language. People have bad impressions of it because they only associate it with browser programming, which is traditionally fundamentally difficult because of things like Internet Explorer 6 and all the differences in the DOM. It's the DOM API that is actually the source of most people's frustrations. But JavaScript, the language, really takes more of the heat, whereas it should not. And in case you think I'm the only person who's crazy who thinks we should write a lot of JavaScript, all these applications on the bottom that Google has written, they're in JavaScript. A lot of people assume that the Google Web Toolkit is responsible for everything that Google produces. That's not the case. Part of it was also just due to history that some of these applications had already been built up and were going, and rewriting it in GWT doesn't seem like a good option. But also, sometimes there are just performance characteristics or metrics that we wanted these applications to meet, and it just made a lot of sense to write them in JavaScript. And all these are basically powered by Clojure. So at the same time, I'm telling you that you should write a lot of JavaScript, and yet in some ways JavaScript tries to defeat programming in the large. So unlike Java, there's no namespaces. There's no import statement that is part of the language in JavaScript. And namespaces are important because as you build up a lot of code, you need some way to modularize it. You need some way to organize it. Namespaces turn out to be a pretty good mechanism for doing that sort of thing. Visibility controls are another important point. So in particular, in terms of object-oriented programming, in Java, you have the private, public, protected keywords. You're saying this data should only be seen by these, the methods that belong to this class. This also is helpful in programming in the large because then this further helps you modularize your code, modularize data, and it's enforced by the compiler. So you get some static checking about this organization, and you don't have to manage it yourself. Similarly, having a type system. A lot of people like the idea that JavaScript is what many people call duck typed, that if you get an object and it has the properties that you want, then you can use it the way that you want to, as opposed to having to create an explicit class and having methods with strongly typed signatures saying this takes a string, this takes a number, and the compiler won't let you do anything that violates that contract. But as you write more and more JavaScript and you just pick up people's code and you're just trying to look at the interface, this can actually be kind of difficult. I myself find this somewhat troubling when I look at Python documentation. Python's also not strongly typed. a lot of times what the method does would be more obvious if I just knew the type signature that were associated with it. So as you write more and more code, this can become a problem. It's also related to refactoring, which I will probably get into later. Also static checking. So this is related to having a type system. So when you have a type system and you have a compiler that enforces types, that means at compile time, the compiler can help you find a whole class of errors that you might not find while running your problem. But similarly, if you have an error in an else branch, I'm sure many Python programmers have hit this problem, where you have, or any branch of code, I should say, where it's just not executed regularly, or say some sort of error handling code, because obviously you want to test with good inputs, and no one ever tests their bad inputs, because why would we ever have bad inputs? But that people don't find out until runtime, until someone finally happens to trigger that error. There's a large class of problems that happen there that could be checked statically if there were a compiler or some sort of other static analysis tool to perform that checking for you. Again, programming in the large, as your code gets bigger and bigger, it's really hard to manage all these things yourself. And yes, you should be writing unit tests or integration tests that actually exercise all these code paths, but the reality is that most people don't, assuming they write tests at all. And this last one is not having built-in support for templates. So in JavaScript, or any web application, you're usually building up large strings of HTML, because this is the thing that you use to create your user interface in a web browser, is basically with HTML and CSS. Unfortunately, in JavaScript, we don't have multi-line strings, yet we want to create large DOM structures defined in HTML. And then we would really like to have placeholders, so we can kind of basically have a template and substitute things in. If you have a repeated row in a table, right? Like you'd like that row to be a template that you can just reuse and pump out the same structure HTML, but with different variables. And unfortunately, the way strings work in JavaScript today, it's not so straightforward to do that sort of thing. So these are some of the ways that JavaScript tries to maybe defeat or makes it harder to do development in the large. So there's a suite of tools open source by Google called the Closure tools, and that's what the crux of my talk is about. And these tools are useful in general in JavaScript development, but I think their true strength is when you start doing JavaScript development in the large, and that obviously you should start with a small project. It's not a good idea to start with a big project. So at the outset, you may not see the value in these tools, but you might then get to a point where you really wish you had been using them. So let's look at what they are. So the first one is the Closure library. So the Closure library is a library of common utilities, widgets, written in JavaScript. It works across browsers. It works back to IE6. And it's analogous to your jQueries, your MooTools, your YUI, all that sort of thing. All these things are JavaScript libraries that try to abstract away browser differences from you and provide a lot of common functionality. The next tool is Closure templates. So Closure templates is a templating language because we didn't have enough templating languages, but Closure templates does have some unique and important features. And you can use it to, as I mentioned, it's hard to build up strings of HTML and JavaScript using raw JavaScript, but having a separate template language actually makes this a lot easier and also less error prone, as we'll see. And the third tool is the Closure compiler. The Closure compiler is a JavaScript minifier. So that means that you may write your JavaScript full of comments and white space that don't actually contribute to the behavior of your program. But your users who download the JavaScript when they visit your site, they are paying the penalty, so to speak, of download time and parse time when you have these extra bytes. And so you want to use a JavaScript minifier to reduce the size of your JavaScript code. This saves your bandwidth. It saves the user's bandwidth. It starts up, and the user's application will also start up faster because there's less JavaScript to parse, and it got there quicker because it was a smaller file. There are other minifiers out there. There's things like JSMin and Uglify.js, but most of them only focus on minification, whereas the Clojure compiler also does adds static checking, and we'll see more of that in a bit as well. But the most important thing, I think, about the Clojure tools that people don't realize is that the library templates in the compiler, they're all independent tools. You could actually use one of the three on any JavaScript project if that's all you're interested in. But they are, by far and away, most compelling when used together. The results that you get and the improvement in your code are just much more compelling when you put all of these three things together. And I think that this is another area where Clojure is far beyond a lot of the other offerings. Like there is jQuery, there is Mustache.js, there is JSMint. Like there are analogs for all three of these tools. So I can't claim that Clojure invented all of these ideas. However, I think that most of these other projects are done kind of in a silo, whereas the Clojure tools are done knowing the strengths of each other tool in mind, and that's why it really helps to put them together. Excuse me. So to really understand and appreciate the benefit of Clojure tools, first I think we should look at some of the problems that JavaScript developers face today. And maybe you don't even realize that you're having these problems or that you should be doing something better. So here's the first one. I don't know if anyone's used the library Prototype.js. Prototype is a JavaScript library that goes way, way back. And one of its claims to fame was its terseness. So this is a function that Prototype offers. Does anyone have a guess what this function does just by reading it? It does whitespace. Yeah, so it splits your code. It splits your string that you give it on whitespace. Now, if you know that, it's probably because you've used Prototype.js before. But if you have a new person to your project and they came upon this function that says $W, it's pretty hard for them to come up with what it does without either running it or looking at the code. And for one function, that's fine. But if this is kind of how you design your whole library, basically to be unreadable but terse, this is gonna hurt you when you're trying to build a large JavaScript application. For a long time, people have kind of gotten away with or justified this type of library style because of arguing that, well, it's saving my users bandwidth because I'm using fewer bytes for my function names, and so it's saving space on the wire, and therefore it's OK to do things that no one else understands. But with things like the Clojure compiler, which will rename variables for you, as we'll see in a bit, that's no longer as compelling a reason to do things in that way. So in the Clojure world, you're really going to want to use names that are readable and make sense to your teammates and are more self-documenting. Another thing is building up strings of HTML. So the problem is as I mentioned, that JavaScript is not really great at this when you want to kind of preserve the formatting of the HTML and the structure that you're trying to produce such that it's readable. You want it to be close to what it would be if you wrote HTML yourself. But does anyone know what this function would return? So actually, this function, if you just ran it, regardless of what inputs you gave to it, this function returns undefined. And the reason is that JavaScript has this neat feature called semicolon insertion. And basically, it infers, if you don't use semicolons everywhere, it infers where semicolons can be placed. And so unlike some other languages, you can have logic after a return statement in JavaScript. It's actually kind of helpful during debugging if you want to exit out real quick while testing something. But in your production code, this is actually kind of a disaster. So what happens is JavaScript inserts a semicolon basically after where that end character would be, or the interpreter or the runtime does this. And then it does this because then there's a new line, and then this whole statement, this on its own is a valid JavaScript statement. So the first line just becomes return. It returns undefined. That statement below it never gets executed. There's lots of little bugs that are errors that people make around this type of behavior. And when it comes to things like formatting HTML, it makes it particularly worse. Another thing problem that people open themselves up to when they write code in this manner is that these arguments are not HTML escaped. So meaning that if the user is some sort of user, and potentially a malicious user, is responsible for, if you read these values out of a database that a user chose when they signed up or filled out a form or something like that, if you don't escape the less than signs and whatnot before you blitz this string of HTML into your application, you could open yourself up to a cross-site scripting attack, which is very embarrassing for you. I've done it. I was very embarrassed, as you might imagine. But it's better to have a tool that really makes it harder to make these kinds of mistakes. Another issue is managing dependencies in JavaScript. So I look at a lot of projects or even websites I visit, and I wonder why they're slow. And then I take a little look under the hood, and a lot of them manage their dependencies in this way. And I can imagine what's going through the developer's mind as they come up with HTML. So they're like, all right, number one, I'm writing JavaScript, so I need jQuery, because everyone says jQuery is cool, so that's what I'm going to do. So they put the script head to jQuery in their page. So far, that's completely fine. But then they get to the point where they have some form that needs people to input a date. And they're like, all right, I need a date picker. And they go and they download a date picker library from somewhere, and they just like plop another script tag in there. So now it's 2 tags. Not so bad, right? I'm probably going to need maybe a date picker other places. That's OK. And then they decide that they want some template solution, because that would kind of help them out. And they didn't get one out of the box with jQuery or with the date picker, so they include that. And then they started testing on IE6, and they're like, oh, son of a, like, now I got to add this workaround, and it's not that big, so everyone can just get it. It's just another script tag and that type of thing. And then, actually, I also forgot I should probably write my application, too, while I'm doing all this other JavaScript development. And you see lots of pages like this where everything gets built up. There's also a good chance that unrelated template solution.js happened to bundle jQuery in their implementation, and now you're pulling down 2 versions of it. I've seen a lot of things like this. So how long can this go on? How many script tags can you add to your web page? Well, a lot, unfortunately, and this is a big source of slowness. If you've looked at page speed or any of Steve Stouter's work on how to make faster websites, everyone will tell you, one, like, you need to minimize the number of requests that your page makes. Sometimes you may want to split things up to leverage caching. That really kind of depends on the profile of your page or the assets that you're trying to download. But if you see something like this, you're probably doing something wrong, and you could be doing something a lot better. And also that a lot of these disparate libraries are probably implementing or re-implementing the same functionality, and your users are now downloading it 5 times. So managing dependencies, again, like I said, there was no import statement in JavaScript, so it's somewhat difficult to do out of the box. Another thing that I've seen happening recently is creating a special version of your JavaScript for mobile. And creating a special version of your JavaScript for mobile is a good thing, because they have different capabilities and that sort of thing. But the problem is that when I see forks of libraries, so there's a library out called Zepto.js, and it's basically a mobile WebKit implementation of jQuery. So when I say mobile WebKit, I mean you can rely on an array having a for each library, or that that the query selector method is available in the DOM, as opposed to in jQuery. To be backwards compatible, there's substantial code that it bundles to be able to emulate query selector all and iterating over an array and a whole bunch of things like that. And so instead of trying to write one library, right, and not repeating yourself, and then doing some sort of post-processing to generate what would be a mobile WebKit optimized version, and then generating what's, let's say, a browser-agnostic version, people sometimes just choose to fork things. And obviously, then it's much harder to maintain. You have 2 versions. One has features that the other one doesn't. Testing, all the efforts of what you're trying to do are now doubled. Another one is safeguarding private variables. So again, because we have no idea of visibility keywords in JavaScript, there's no public-private keyword. A lot of people use closures to create or to emulate the private variables in languages like Java. And so this is an implementation of how you could do this. If you imagine immutable lat long, if you treated that as a constructor, you passed in the lat long. You wanted there to be getters for these properties, but not setters. This would do that for you. The downside is that that means every time you instantiate one of these objects, in this case, it's creating 3 new function objects as opposed to sharing one method object. So this will take up more memory. It also increases lookup time, because by using a closure, you actually create an extra level of scope. Newer engines like V8, this shouldn't actually be a significant difference in terms of the lookup time, but older browsers like IE6, these things actually become more significant. And another thing is documenting types. So as I mentioned, we don't have a standard syntax for documenting types of variables and methods in JavaScript. But if you're going to have a large application and people want to be able to look at an API really quickly, it's more helpful if you have some sort of standard way to document types. Sometimes libraries, so this is what Dojo does basically, is that you can make a little inline comment. And this is actually pretty good, as long as you have kind of a standard format. But even in this example, you say you have a method that takes some number of parameters, and then you also specify a callback function. And a lot of people just say the callback is a function, but really that callback has a contract, and in this case, it would say be something that takes a lot long. But developers right now usually have to take a look at the implementation of the method to see what the callback actually gets or test it out, because it's not expressed in the type definition that you gave for the argument. It's a lot easier to pick up a library and use it if you know what the contract of the callback function is. Helps you figure out what you should send it, or actually even if it's the right method that you should be using or not. So these are a bunch of problems that JavaScript developers have today. And so I want to go through the Clojure tools, and let's take a look at how Clojure can help you address these problems, write better code, and avoid these pitfalls, and hopefully avoid bugs. So the first thing is, this is basically how, when you use all the Clojure tools together, how your application is built, or how you produce JavaScript at the bottom. So at the top, so one thing you'd have template code. And so I'll show you in a second. Clojure templates is its own templating language. So you write your templates in that templating language. And then you run it through the tool, Clojure templates, and that produces JavaScript. So now each template that you wrote becomes a JavaScript function. The Clojure library, as I said, is already a library in pure JavaScript. So now you already have your JavaScript libraries for string and DOM utilities and all sorts of other good stuff. And then the third is your application code. So you're able to write code that leverages both the templates and the library code that you've written. And all three of these things go down into the Clojure compiler. And so the Clojure compiler is a whole program optimizing compiler, meaning that it has all the source code of your application at once when it compiles it. This is unlike, let's say, Java, for example, where some of the assets that go through Java-C are jars, are precompiled objects, and that therefore there's some optimizations that the Clojure compiler can do on a global level because it has all of the source code. And then as a result, we get some optimized JavaScript. We get something that the Clojure compiler has produced, knowing that all possible code paths, so to speak, of your JavaScript application. And so this is what enables it to produce something that's really small, really compact, and really fast. So the first thing I want to show you is what the syntax for Clojure templates looks like. So there's a namespace at the top. In this case, I made a namespace called widget. This looks like, I guess it looks kind of like Java or Javadoc, where you declare the parameters that are going to be passed into the template. So these are basically your template variables. And then you have below, then you have your HTML, and we have this $sign placeholder type of thing, which is probably not too surprising if you've looked at most other templating solutions, right? There's the markup, and then there's the stuff that you want to insert. So at the outset, this maybe it doesn't look too compelling. But what's more interesting is that when we run this through the Clojure templates tool, and so this is what is produced once you run it through the tool. So what's actually produced is a function. So unlike PHP, where PHP is also a templating library, where you can't really get access to it programmatically. It's kind of like you just hit the page and stuff just happens. Now, this template is actually a function. It has a parameter, it has a return type. You can see that it takes this object in, And another thing it does for you is that by default, you can see that all the arguments are escaped. So I made that comment earlier about my original definition or a function that you tried to do this template, where that the arguments were not escaped and you were subject to cross-site scripting vulnerabilities. In closure templates, it escapes things by default. You can add annotations to say, don't escape anything in this template or don't escape this variable, but by default, that you should be a lot safer. Another thing is also that just by this being a function as opposed to something that you can interact with programmatically, you can, if you're familiar with the idea of function currying, and also that in JavaScript that functions are first-order objects that you can pass them around. So programmatically, this is like a much nicer way to deal with the idea of a template. Also, you can see if you look carefully, all the white space that we put in the template just to make it readable for ourselves is removed when it's translated into a JavaScript function. So this saves bytes. When you traverse the DOM, there's actually fewer white space nodes that get in the way. So these are all nice things and help you create markup that's basically as trim as it can possibly be. Also, I want to point out that there's these statements that got inserted at the top, which are Goog provide and Goog require. These are functions that are part of the closure library. This is basically how namespaces are declared and how dependencies are expressed in the closure library. So as I said, there's no native import function in JavaScript, but when you write your code with the closure library in this style, now you have a standard way of expressing dependencies, and we'll see the benefits of that in just a second. So the first thing is now if we have this template function, and now we want to use it. So now this file, we said we provide this namespace called widget. Now we'll have some application logic where we want to use it. So now there's a Goog require statement for widget. And we're actually ourselves going to provide a new namespace called button. So here we add a method to the button namespace by declaring it as a property on the button object. And the button object got created as a side effect of running that Goog provide statement. And now we add it as a property. It's just a function. All templates take one argument, where the argument is an object literal, where the names of the properties are the values for the template, and the values of the property are the values for the template values. And so basically, we create this data object, and now we can just pass it to widget.button as a function, return the value, and return that from getButton.html. So many people find this to be much more maintainable, because now when you want to write your markup, you can basically do it in any way that you want. You can actually put comments in this template that don't get included as part of the markup that's sent out. And you really want to write this, but you don't want to write it by hand, but that's what you really want produced. And now you have that, and now you can use that inside your regular JavaScript function. So now we're just really working in the JavaScript world. So as I mentioned, there are these dependencies that we've expressed through Goog provide and Goog require. So at the top, we have button, which we said requires widget. And widget requires soy, which is the internal name of closure templates. So you'll see that if you look through closure code. When you see soy, it means closure templates. And in practice, closure templates by default include a bunch of stuff. It includes DOM utilities, because a lot of times you want to take the result of a template and put it into a DOM node or create a document fragment out of it. It includes string utilities for doing the escaping. And it also includes a lot of utilities for internationalization. So there's actually support for internationalization. In closure templates, there's a special message tag. So if you're building an application that you want to localize, closure templates helps with that as well. But the thing is, though, in the example that I gave, we're actually not using all that stuff, right? We never used the DOM utilities. We never used internationalization. A lot of people will choose to maintain these dependencies by hand, saying, oh, I don't want to include all that stuff. But as we'll see, the closure compiler will take care of that for you. So it's OK to create large libraries where you, in practice later, only use some of the functions, because you're going to want to supply these libraries to, say, other teammates or for other projects that you may use. So in practice, we'll see how actually the DOM utilities and the internationalization stuff gets stripped out, and you don't pay some penalty for using a more mature library. So for example, if in terms of leveraging dependencies, we'll introduce a new one called myApp. So now let's say this is your application. And now you require a button, and you require some DOM utilities, and now you have a function that goes ahead and uses the template and inserts it into the DOM with these standard DOM utilities. So now the dependency graph for your application has changed. Now we have a new thing at the root of the graph called myApp. It depends on button, and its dependencies still go all the way down. But now myApp depends on DOM, and so now actually that DOM dependency is going to come back into our code, but the internationalization one will still be separated. This is really nice because this all happens naturally when we start, as we'll see with the Clojure compiler, as opposed to trying to manage all those script tags by hand and trying to figure out what the dependency ordering is and trying to find the minimal set because you want to send down the least JavaScript code as possible. So kind of jumping right into the Clojure compiler and looking at some of the effects. So the Clojure compiler now, with code that is written in this style and it understands these Goog provide and Goog require statements, now this is where it gets pretty serious in terms of the savings that it can give you in terms of your JavaScript code size. So by default, if you just concatenated all the files that would be transitively required by that myapp.js file that I created, it's 375K approximately. Very, very large. That is a lot of code, especially for something as trivial that we were doing. We were just building up some HTML and inserting it into a DOM. So that does seem a bit excessive. But then if you run the Clojure compiler, there's a mode called whitespace only, where all it does is remove whitespace and comments. This already gets you down quite a bit. So as you may guess, the Clojure library is actually pretty well documented since that got rid of almost 75% of the code. So that's a pretty big win right there. By comparison, I also ran the same code through YUI compressor and Uglify.js. These are some other minifiers that are popular right now. You can see they do a bit better than whitespace only mode. And the Clojure compiler also has a simple mode, which is analogous to the YUI compressor and Uglify.js. And you can see it just ekes them out by a little bit, but we're not looking at an order of magnitude difference until we look at the advanced mode of the Clojure compiler. The advanced mode is quite a different animal. Basically, what it can do is, like as I mentioned, it's a whole program optimizing compiler. So it basically traces the code paths from the main method, from this main method. So this is the only function that's actually called in this application, and it can trace through and realize that, okay, the only things that are called are getButtonHTML and getElement, and so on and so forth. And then when it's done optimizing, it will only include the bits that it needs, that it's determined that will be exercised by this JavaScript application. So now we've gotten down to something that's 1/200th of the original size of what we were dealing with. This is obviously a much better way to let a tool do this for you than do this type of thing by hand. And even to go one step further is that you can enable options to eliminate platform-specific code. So if you have these special defines, these special options passed to the compiler, you can say, assume that it's mobile WebKit, and also assume it's not JScript, which is the engine in Internet Explorer. And in this particular example, this won't be true for all examples, but it gets the whole program down to 481 bytes, which is basically nothing. And this is all being done for you as opposed to you trying to reorganize your code and optimize it by hand in order to get the same result. So again, this is also comes back to, I mentioned that library Zepto.js and jQuery, where people are making these forks, where instead, if they were just writing their code in a way that you could eliminate blocks of code using the compiler, then they could share much more of the common code as opposed to having to do a giant fork, which is much harder to keep in sync. So if we look, this is the output of the Clojure compiler. It's very, very compact. I was at the JavaScript conference last week, and someone made the astute remark of, I don't want to be a compiler. I want a compiler to be a compiler. And I think that's a good adage. But right now, we see a lot of people just trying to use short variable names and some other things and trying to do it all by hand. But no one is going to write this type of code by hand. But even though this is really what we want produced at the outset. And as your application gets larger and larger, it's even more important because you would imagine that example with 5 script tags, you could imagine someone coming up with, growing their application to be 20 script tags, and then someone copy pastes it because they think it's what they need for their next project. It's just not a way to do large JavaScript development, especially when it's really important that something really compact like what you see here is the result. Another important thing to think about as well is that as our applications are getting larger in JavaScript, that there's a lot more IP, intellectual property, that's going into these things that we're sending down to your users. And if you've built a very large JavaScript application, and now say you're putting it on the Chrome web store or various other places, you don't want to be giving your source code away necessarily. So even though it's not the primary goal of the compiler, it also effectively serves as an obfuscator and makes it much more difficult for someone to take the code that they get and then add their own features to it and then claim it as their own. So that's another aspect I think that's kind of unique to development in the large right now, is that the bulk of the code is so much more interesting. It took you so much more time to build up if you're doing it for business reasons, that you need to have a better way to protect it. Also, there's, as I mentioned, there's no type system built into JavaScript natively. So one of the better ways to approximate it is by using basically something like annotations. And this is what we see here. We have some JS doc, as we call it, and where we have app param tags like you're kind of accustomed to from Java. But then the thing in curly braces is what's called a type expression. And it basically says, these are the valid types that can be passed in for this argument. We also have this annotation for a constructor. So that basically says that if the compiler sees you using this lat long function but not using it with the new keyword, it will yell at you because it recognizes that this is a constructor. It is something that's meant to be instantiated. It's not an ordinary function. Similarly, there's also this at private annotation. And it's not on by default, but you can add a check to the compiler that says make sure all accesses to something annotated with at private are only done from what's inside a closure class. So again, as opposed to creating those somewhat clunky closures, now you have a way that better communicates what you're trying to do much more succinctly, just saying at private. And it also eliminates that runtime overhead you had before of creating a closure. Now, instead of calling a getter method, the compiler can change those getter methods into direct property lookups. It can inline them, and this can further reduce code size and improve runtime performance. These type expressions, they also enable static typing. So the compiler can also has logic to enforce your type. So just something that you're accustomed from the Java compiler or any other very strongly typed language, this is something that you can turn on and have it check to make sure that the contracts that you've declared are being honored. It actually is able to work with partial type information in that you may not document the types for all your functions, but where you do, the compiler will leverage it, and where you don't, it'll basically make a best effort, but it shouldn't return false positives. Finally, there's a rich type expression language. So as I mentioned before, we often see things where someone just declares a callback. Now there's actually a standard way, or at least from the perspective of the closure compiler, so that you can say, this is a function that takes a lat long object, which may be null, which is what the question mark at the front of that lat long signifies. You can also specify if it's a var arg function, the type of its return type. This one didn't happen to have a return type. And this is a win both for the compiler because it's able to do type checking on more complex expressions like functions, but also for your developers because they can go and run through the code and look really quickly like, oh, I just need to pass a function that takes a lat long, excellent, as opposed to having to dig through the code to figure out exactly what it does. So to try to bring it all together, JavaScript code bases are getting larger. I mean, I think the Chromebooks announcement today is also very exciting in this regard, in that people are going to want to make bigger and bigger apps. They're going to have to be in JavaScript at some level, either translated from GWT or writing them directly, especially if you want them to work offline, because then all you have when it works offline is JavaScript, HTML, and CSS. So as we were bringing more complex code bases to the web, that there are more complex applications, excuse me, these code bases are going to get larger. And JavaScript, unfortunately, was not designed for programming in the large. And so one way is to try to escape it and run to another programming language, but another option is to try to tame it, so to speak, with the closure tools. And that is what in my experience has worked quite well. And so I encourage you not to run from JavaScript, but to give it a big bear hug instead, and use the closure tools to tame it so that it can grow, your application can grow, but not grow out of hand. So thank you very much, and I now have time for questions. Yep.
I'm not sure I know anybody who's starting on a really big JavaScript project. So we all already have JavaScript projects. And we're probably not using closure tools. Very few people are outside of Google, I feel like. How do you transition a very, very large project, I mean, the sort of project that would actually benefit from closure tools, onto it without okay, well, we're just going to spend the next 3 months writing comments?
Right. So I think, like any migration, you certainly want to do it in pieces, and you obviously don't want to hold up prevent yourself from making any sort of forward progress, right, while you're in transition. So the first thing I would say is using Goog provide and Goog require, having some scaffolding to express the dependencies in your application. I would say that is step one. Step two is then you probably have some existing logic for things like registering event listeners or array utilities. And then I think what you do is you choose one at a time to kind of swap out what your homebrewed solution with the closure library equivalent, and then you progressively do that. I mean, this is also what happened inside Google. Like the library didn't exist forever, and we had long-running applications that were already built up. And it was the same problem, because you don't want to just copy it all in one day, because then your application doubles in size, and that's not really great for your users either. So I think you definitely want to stage it, and you definitely want to create the scaffolding with the require and provide, and then move things in as you go forward.
I should clarify. We're already using Dojo, provide and require, so we already have something in place. Certainly we could replace them with Googs, no problem. But it's actually really the closure compiler, which seems like it's an all or nothing thing. Like either everything is marked up with comment, so it knows what to delete, or it deletes your application.
Right. So there's as I showed, the closure compiler does have different modes. So there's simple mode,
but
for example.
I really want advanced mode. That's where I feel like I get the big benefit. How do I ever get there? It's a million miles away.
Right. So I think that some people in the Dojo community, well, I'm sure that more than some are interested in this as well. Another thing you can do is the compiler is open source. It is written in Java, and it has its own plugin system such that you can write new compiler passes. So if you have if you feel like your code base is too large to migrate, the right thing to do, or the simplest thing to do, as simple as writing compiler code is, but is to write your own pass. And fortunately, the closure compiler has a lot of passes already, and they're also very well unit tested. So if you break something, it'll be pretty clear, and you also have a lot of sample code to go off of. So you might want to write your own pass that understands Dojo a bit better, and then that may be the best way for you to leverage it.
So we don't have a lot of even Dojo doc comments in there. I mean, like.
What do you have?
we've got comments. We've got sort of ordinary comments, but we didn't make type parameter comments. So who would, right? What's the point of those?
Right. So there's, type checking is an option of the advanced mode to get the minification. It's not a requirement. So you don't have to have everything marked up with type expressions to even use advanced mode necessarily. It's just, it's more helpful if you do, but it's not a hard and fast requirement.
If I have half my code marked up with, or a 100th of my code marked up with type parameters, can I use that at all? Or?
Yeah, absolutely. So basically, every time you omit a type expression, it assumes that the type expression would be asterisk, which means the any type. And so, so it already has mechanisms to deal with that situation.
So if I just replace all my Dojo requires with Goog requires and run the advanced compiler, what's about to happen? It's going to delete my application, right?
There are some other caveats that are actually well documented on the website in terms of things like quoting properties is a common one, and that's probably the biggest one off the top of my head. But I think most Dojo code is pretty similar, so I don't think it would be a disaster. But you should certainly there's a very good page on code.google.com that says like hazards of using advanced mode, and it should help you audit your code for those types of things.
Thanks.
All right.
Hi, we have a couple, we have a pretty big JavaScript project, probably a couple megs of source or something, big project. But we switched over to the Clojure compiler last summer, and we've been totally thrilled with it. But this is the first time we've seen the templates, and I think it's something that we're interested in. I am curious because it looks like you have to run a compiler pass just to use them. Is there any? So I know we're using the advanced mode compilation or whatever, but you can run it uncompiled, and the GUG requires just do XHR request, get the code and eval them and stuff. Is there an equivalent for those templates that you can run them straight from source, or because at this point running the compiler takes some time because you have a big project.
Yeah. So I built a tool. I, for a reason, neglected to put it in my slides. It's called Plover. The book, my O'Reilly animal is a golden plover, so I named it my tool Plover without an E because I want to be cool like Flickr. But if you take a look, what it does is it has some modes that basically you can just point it at a directory of JavaScript and soy, or Clojure templates files, and it will just spin up and serve them from disk. And the JS ones it'll serve verbatim, and the .soy for files for Clojure templates, it'll translate them on the fly. So your development, you can still debug basically what is raw code, but not have to run the compiler over everything to get that. Because I understand that for larger code bases, it is a bit slower.
Okay, cool, thanks.
I actually got 2 questions for you. The first question is about browser native functionality. Does the Clojure compiler, is it smart enough to detect that kind of functionality? And then if so, when new browser capable features come out, what's the delay time between the library getting updated versus not, and being able to support those?
So that's a good question. I guess so basically you're writing in JavaScript. So if it's there, you can test in JavaScript as you normally would, right? You could say if document.body query selector all, and then do one thing, and if not, do another thing. But there's also this idea, when using the compiler in advanced mode, this idea of what's called externs, where you basically say, these are all the symbols that are going to exist in the environment in which my code runs, and their type definitions. So document and window and that sort of thing. Because as you saw, the Clojure compiler renamed a whole bunch of variables, but it can't rename the built-ins like document and window. So when you're talking about browser features, those are usually listed in these externs files that declare basically what's in the browser environment. Those are updated pretty quickly, I would say, because a lot of projects at Google are pushing the envelope. So in that sense, the compiler, the time to a feature coming out to being used by the compiler, I'd say, or available or recognized by the compiler is pretty small.
My second question was about development. It looks like you don't get that minified code until after you've run through the compiler, which makes sense. When I'm doing actual development and I'm debugging with Firebug or Chrome's developer tools, do I have to load up all 150 or whatever megabyte of those library files?
It depends how you do it. So one thing you can also do with the Clojure compiler, which I didn't demonstrate today, is you can have this idea of modules. So GWT has this idea of code splitting, where you can say, when I'm only using up to this feature, then only include these JavaScript files. And then if the user starts using this other feature, then pull down these other files. So one really good technique is to use this modules feature of the compiler, which ultimately will compile optimized version of each of those clumps of code and will understand or depend on the symbols that exist in the code that's already loaded. So basically, you're only loading the minimal set of files for the functionality you need it right now. And as users say, goes to the settings page, and now they need the settings code, now it'll pull that down basically on demand. So and this works in development too. So it'll only be the individual files that contribute to say what I'm calling a module. So you don't have to necessarily load everything when you start up.
Okay, thanks.
Just one more?
Oh, sorry.
This kind of relates.
The lights are bright.
This kind of relates to the first question. You had that one slide where you had the prototype with the $W. I've used Clojure, done some newer projects, but I have a lot of legacy projects with prototype. Will the compiler deal with those type of commands to compile them down, or do you have to pretty much remove all the prototype to get the compiler to work?
Well, no. So if you supply the prototype source code as an input to the compiler, it will treat it like any other input. And also so unused functions will then also still go away. And interestingly, if you have a function that you use a lot in the Clojure library and it has a very verbose name, the compiler will, will pick the smallest names for the functions that are used the most. So they might, it's possible your prototype functions could get renamed to longer things, although they're only 2 bytes, so it's probably not actually going to be longer. But basically, sorry, the short answer to your question is yes. Like you can use the prototype code with the compiler.
Thanks.
So one of the most fun things in the world about doing JavaScript is after you've minified it, that you get a bug report from the field. So is there any equivalent to a symbol table or something that could be added in and say a less than perfectly optimized?
Yep, yeah. And so basically, there's an option when you run the compiler to output as a byproduct a thing called a source map. And so it is a reverse mapping of, it's actually every line and character in your compiled code to the line and character position in the original source code. The only downside, and then there's some other Java code that's there for taking a stack trace, a JavaScript stack trace from the server and converting it into the unobfuscated JavaScript file. The only caveat is that you really care about the line and the character offset. And I believe right now only Chrome, and I guess probably then Safari, provide both the line and the character. Most of the other browsers only do the line. I haven't checked Firefox 4, but at least Firefox 3.6 still only sent the line number. So if anyone has influence over any of those folks, it would be great if they also sent character offsets, because to exactly the point that you're making.
Is Clojure planning to implement the common module dependency, common JS standard?
That's a good question. So there is no plan and there's no anti-plan, so as far as I know. In that, like, they're not hating on it, and they maybe haven't figured out exactly how to merge the two worlds. I think if there were a good proposal put forth on how to combine those two things, I think the people who work on Clojure would be very interested in making that happen.
Are you still working on Clojure, or is that something Google works on and you don't work on anymore?
I contribute to Clojure for sure, and I certainly talk to those folks, and we had a discussion just last week about it, and it was kind of like one of the many items on the list. So it's certainly something we'd like to address, but it hasn't bubbled to the top yet.
Thank you.
Cool. Anybody else? All right, thank you everyone. I hope you enjoyed Google I/O.